All right, Unit 3, Lesson 3, Graphing Systems of Linear Inequalities. So I know towards the end of the last unit we covered graphing linear inequalities one at a time. In this lesson we are going to be graphing two or more linear inequalities at a time. So for graphing these linear inequalities, you can use either method. You can use the method we talked about with finding the intercepts, or you can use slope-intercept form, y equals mx plus b. And I'm going to show you some of the steps for that, because that maybe will be easier to decide which side to shade as well, so we'll talk about that. And we graph solid line or dashed line, and then we decide what that line will look like. We shade whichever half plane, whichever side of the line represents the solutions, and then we repeat those steps for other inequalities. So the thing to notice here is the solution will be the overlapped region. So when we graph these, I just want us to graph the lines, and then at the end decide what the overlap is instead of shading and having all this stuff shaded and a big mess on our hands. So I'm going to show you what I mean by that. So with this first equation, I'm going to do this first equation in red. So I'm just going to put a little red mark to show that this is going to be red. That's kind of like y equals mx plus b. I know that line will be dashed because it's just less than, and that has a y-intercept of 1, a slope of 2, so up to right 1. And it's a dashed line. So I'm just going to draw a dashed line. And I'm not going to shade right now. In the next equation, it's got a y-intercept of -3. Well, actually first, I'll make that one blue. It's got a y-intercept of -3 and a slope of -1. It's going to look something like this. And that is less than or equal to, so that is a solid line. Now, before I shade, I'm going to look at both of these. And it's important to kind of know when it's y equals mx plus b, it's easier to determine the shading because less than or greater than is a little bit easier to determine. So for our first line, less than would be this side of the line over here, okay? For our other equation, less than would be this side of that line. So we are shading underneath the area that is underneath both lines. So I'm going to show you that area. That would be this area, would be the overlap of shading underneath both of these lines. Okay? Because if I shaded everything for the first line, I'll do red, I would shade all of this for less than. And for the other line, less than, I would shade all of this. So it's noticing that the overlap is this area right here. So all you need to shade is the overlap when you're graphing. In the next example, the first equation is already in y equals mx plus b, which makes it, I think, easier to graph. So I got y-intercept of 1, slope of -3/4. So I go down 1, 2, 3, right? 1, 2, 3, 4 from the y-intercept. And that is a solid line. For my other inequality, it's not in y equals mx plus b form. So I'm going to show you guys how to do that. So 3x plus 4y is greater than 16. So it's only a couple steps to get this into y equals mx plus b form. First step, to solve for y, subtract 3x from both sides. So I've got 4y is greater than -3x plus 16. And then my next step, my final step, divide everything by 4. So my inequality is -3/4 x plus 4. So that makes it a little bit easier to graph. Y-intercept of 1, 2, 3, 4. Slope of -3/4, 1, 2, 3, 1, 2, 3, 4. And that's going to be a dashed line because it's just greater than. So if we're thinking about shading, for my first line, it is less than, so I would shade down here. For my second line, it's greater than, so I would shade up here. Well, if we think about the solutions as being the overlap, these inequalities have 0 overlap, so that is why these inequalities will have no solutions. No solutions, because their solutions do not overlap whatsoever. Okay? So getting that into y equals mx plus b form, I think that's a little bit more efficient way of graphing it. Okay? Hopefully that helps a little bit. And then determining less than or greater than, think above or below the line. So I'm going to have you try the guided practice. Again, pause that video, take some time to work through this on your own, and just use my answers as a way to check, okay? And if it's totally different and you still don't know, let me know, and I'm still here to help, all right? These videos are meant so you can kind of work through this part of the lesson at your own pace. Okay, so to explain these two examples for guided practice, number one, they're both in y equals mx plus b form. So I can just use y-intercept and slope to graph these. So the first line is dashed, second line is solid, and it's above this, so shading, it's above this red line, but below the blue line. So what region represents that overlap? That would be this region right here, okay? That's why I shaded just the overlap. I think that's a little bit, for me, it's a little bit cleaner graph. It helps you see what the solutions are a little bit easier, I think. In the second example here, I had you solve for y. So if you solve for y of that first equation, it's y is greater than 1/3 x minus 2, creates a dashed line. Second line is already in slope-intercept form, so you can graph that a little bit more easily. And then the overlap is above the red line, but below the blue line. So the shaded region, that's the overlap, is this green in between the two lines. So I'm going to show you an example of a line and an absolute value inequality, and then I'm going to move to some context problems. So this next example, example 3, y is less than or equal to 4. I'm going to graph the line y is less than or equal to 4. It's going to be a horizontal line. Yours is going to be straighter looking than mine at 4. And then this absolute value, and it's remembering some of those transformations. So it's remembering that vertex of that absolute value equation is going to be the point 2, 1. So I'm going to graph the point 2, 1. And then counting from that, I'm going to go up 1, right 1 from each of these. And the tricky part with this one, it's going to look a little goofy because it's a dashed line, because it's just greater than. So I'm going to draw a dashed line the best I can. And however you draw your dashed line is up to you. I just got to know that it's not solid. So if I am talking about the overlap of these two inequalities, it is below the red line, but above this V shape, absolute value graph. So the overlap would actually be right here, okay? So this is extension a little bit. This is a little tougher because I'm taking quite a bit of information that we've learned from the last unit and applying it into the same problem, okay? So, example 4. This is mainly just being able to write an equation, write the graph, or draw the graph, and interpret it. So, it says you're selling pizzas to raise money for a school field trip. Cheese pizzas cost $8, pepperoni pizzas cost $9. You need to sell at least 2 of each pizza type, and you want to sell at least $144 worth of pizzas. So, the graph kind of gives it away, but X is cheese, Y is pepperoni. So an inequality that I could write is to represent my sales, I could take cheese pizzas at $8 a pizza. $8 a pizza times X cheese pizzas would represent my sales for cheese pizzas. And then plus $9 a pizza for Y pepperoni pizzas. So that expression represents my sales. And I want to sell at least $144. So that means $144 or more. So my sales need to be greater than or equal to $144 to meet my goal. The other important thing here is there's actually two more inequalities. You need to sell at least 2 of each pizza by type. So that means my amount X of cheese pizzas has to be greater than or equal to 2. The amount Y of pepperoni pizzas has to be greater than or equal to 2. Okay? So, for me to graph this, you're going to see me graph 3 distinct lines here. Okay? So, X is greater than or equal to 2. I'm going to draw a vertical line at 2. And then I'm going to draw a horizontal line at 2 to represent the minimum amount of pepperoni I can buy. And then from there, I'm going to graph this 8x plus 9y equals 1 is greater than or equal to 144. So if I'm going to solve that and do the y equals mx plus b, this would become 9y is greater than or equal to negative 8x plus 144. And then I would divide everything by 9. If I wanted to do y equals mx plus b. If you're comfortable with finding the intercepts and doing it that way, that is totally fine. So I get my y-intercept is 16. So this will look a little bit weird at first, but you'll see kind of how this graphs out. So 16 is my y-intercept. I'm going to graph that up here. And I go down 8, right 9. So down 8, right 9 would be just about right here. If I go down another 8 and write another 9, I find out my x-intercept would be 18. So I'm going to need some sort of ruler to try and draw this straighter than I have been the other one. So let's see if that works. That's better. So if we're trying to graph the overlap of all these inequalities, all of these are greater than inequalities. So we're going to graph basically above all these lines. So that means above this horizontal line down here, above our slanted line, and to the right of our vertical line. So this whole region here represents all of our solutions. And I'm getting a little sloppy, but that represents all our solutions. Okay? So an extension to that problem is saying you sell 12 cheese and 10 pepperoni. Did you reach your goal? Well, if you graph the point, this would be like the point 12, 10. If you graph that point, does it fall in the shaded region? Yes, we did. Or you could substitute those into the inequality and see if it makes that inequality true. Either way, that works. So, down to the guided practice. I gave you one. This one's a little tougher because it has 3 inequalities. So I want you to try this one and then check your answer with me once you're ready. Okay, so there's a lot going on in this one. So I just wanted to show how to graph each of these, and then I'll show you where the overlap lies. So with this one, y is greater than x minus 1, y equals mx plus b, dashed line, fairly straightforward to graph. For the absolute value, just remembering the vertex is at negative 2, 0, and then I count from that vertex up 1, right 2 as a slope, and then I mirror it over the vertex. And then finally, x is greater than or equal to negative 2, solid vertical line at negative 2. So to make all of this show the overlap, greater than this red line, less than the blue, greater than the green. So that would be, and I'm going to do it in gray here. That would be that area for the shaded region. So you can move on to the practice. It's going to be a lot of graphing. So you're going to need to grab a paper copy from me. So again, use these notes to kind of help you as a guide, and you can move on to the next step in the lesson.